Hello all, nice to be back. In the previous videos, we discussed something regarding engineering graphics, something regarding introduction and some essentials of the subject. Let us continue with some more essential things of the subject. Let us see a couple of things, units and dimensioning. Let us start with units. In general, if you look at a diagram, we need to quantify things. In order to quantify, we need a standard. Once when we give a magnitude along with the standard, the diagram gets quantified. So we need to look at the unit. In a diagram, mostly the thing what we use is a length. So we need to look at the units that are being used for a length. The units that are being used for length changes from place to place, from time to time, even from people to people. In general, if you look at the popular units among people, we can make a note like this. It's metric and imperial. If you look at metric, the things deal with meter. If you come down, it is millimeter, centimeter, it goes on that way. Even there are things well below that, like micrometer, nanometer, but we don't use those things in a drawing. So in drawing, we deal with millimeter, centimeter, or a meter. But if you are dealing with a huge thing, just like a map or something like that, we could go with even like a kilometer. So that's about a metric system. On the other side, imperial. In certain people, in certain region, people use inches, foot, or even yard, then chain, furlong, mile. Oh, this is another set of units that are being in use. So we need to be specific what kind of units that we are to use. SI units suggest that we need to follow metric. So let us consider we are following by metric. But we have to be familiar with the other things as well, because it is not everyone following the metric system. Even if you say certain things, how tall am I? If someone asks me, I could say I am 6 feet tall. In the case I am using an imperial system. Or else, if someone is saying my shirt size is to be 40, that is also in imperial system. If a photo frame is given in a maxi size 6x4, that's again in imperial, in inch. But in drawing, we use certain things in millimeter or meter. Even in day-to-day life, we use many things in metric. For example, if we say a distance from a place to place, we could say it is 10 kilometers far away from here. Or else a 400 meter track, a 100 meter race, there we use metric system. So we have to be very much specific what kind of unit that we are using in the drawing. If you look at, we need to focus on this thing as well, because even in engineering drawing, in engineering practice, certain people, those who are making furnitures, or even people, even our forefathers or ancestors, they were much familiar with this thing, imperial units. Even still nowadays, they are following the same thing. So we can't expect them to learn metric system on our overnight. On the other side, we need to learn that thing. So we cannot just convert a drawing from metric to imperial. We need to know about the conversion. For example, if a drawing is made in metric, if it is made in a millimeter, how to convert that into inch? 1 inch is equal to 25.4 millimeter. So by this conversion rate, we will be able to convert it. So we need to know about the units. So units are very important, very important. So we have to be specific what kind of unit is being used in the drawing. Okay, good. So let us know about this thing. So here it is something like millimeter, centimeter. Then up the order it comes meter, or even it goes in kilometer. There are certain things in between as well, but we don't look at those things. Here, inch. If you come down, it's thou, but we don't use those things in a drawing. Inch, foot, or in plural form it is to be given as a feet. Then we use certain things as yard. Then in certain cases we say it as mile. In certain regions, still people are using things in terms of imperial. So we have to be specific. Even our BIS, Bureau of Indian Standards, recommends metric. So what we need to do? We have to be clear what unit that we are to use in the drawing. And we need to know what type of unit is being followed in the drawing what we are reading at. Okay, good. So that's about units. Just make a note on it. It's very important. And about dimensioning. We need to give details about the diagram. For example, if I want to make a component like this, I make a drawing of this and I send this to 2-3 people. What could be the outcome? Maybe if I don't send any details about this, someone could figure it as a huge box and they could make something like this. Another one could make something like a briefcase. Maybe one could make something like this. So unless I give details about this object, it is meaningless. So a drawing without dimension is meaningless. Keep in mind, drawing without dimension is meaningless. So we need to give all the necessary details of a component. All the necessary details of a component. So dimensioning, for example, if I want to give something about a thing, let it be a rectangle. Does this give any meaning? Just it gives the shape, but we don't know the size of it. We need to give something. For example, looking back to the olden days, once when we were in school, we were being taught about a huge thing that is existing in universe or in the world. I have to say, it's a blue whale. How huge is a blue whale? Do we know that? I haven't seen it. So, for example, if it is something like this, it is shown something like this. Do we understand how huge it is? In general, if you look at how huge it is, a person may be something like this. This may be the size of a person in relation to this one. So unless I give this detail, we will not be able to understand how huge this is. So but we don't give such detail to the drawing. We need to give dimensions for the diagram. We need to give something like this, like this. This is this much, this is this much. Unless I give this thing, we will not be able to understand about the drawing. Let us see something more in detail about this one. Let us see dimensioning for these diagrams. Let us consider this rectangle. As I told you, we need to give details. Consider this rectangle. I want to give this length and this length. If I give those two dimensions, that will be sufficient for a rectangle. So first of all, I start for this. In particular, this line is called object line, as I am to give dimension for that line. That line is called object line. I make a line and that is called projection line. Remember, the projection line what I make should be in thin continuous line. Already we have discussed about types of lines, that we saw the various types. Here, this drawing should be made with thick continuous. That is important. That should be seen clearly. Whereas, the dimensioning, this projection line should be made with thin continuous. Now, look at another thing. I have not made contact. There should be a small gap, say to be 1 mm, between the object and the projection line. Now again, I make another thing. Note this one as well. While I make this projection line, that is made perpendicular to this one. Both the things are made perpendicular to the object line. Now again, I make another thing called dimension line. This dimension line is made perpendicular to this one. So this is made perpendicular to this one and this is made perpendicular to this one. So what happened? This dimension line is made parallel to the object line. Now I can give a value to this one. So again, I need to give something from here to here, from here to here, from here to here. This is this much particular value, say to be 100 mm. Yes, I need to give the unit. We discussed about unit. Unless I give the unit, it will become meaningless. So again, from here to here, and it is called termination. There are various methods to give termination. For example, if I start in certain region, they give just a line at 45-degree inclination, or else a small circle this way, or else a open arrowhead. The arrowhead could range included angle from 15 degree to 90 degree. Then a closed arrowhead. This is an open arrowhead. This is a closed arrowhead. And another one. Here it's a closed filled arrowhead. These are some of the types of terminations that are being used. We can select any one of this. I would like to go by this one. So here terminations. So I can opt this one. So from here to there. So I can make this way. I can make an arrowhead. It is closed and it is filled. Now look at the drawing is seen. The arrowheads are seen. The values or a value is also seen. The value should be written above the dimension line. The value should be written above the dimension line. Don't make it below the dimension line, okay? Consider that if I write something like this, it could fall down, okay? Don't make it like that. So the dimensions should be written, dimension value should be written above the dimension line. Here, again I want to give something here. For this particular object line should also be given dimension. So in this case, I give this way. Again I give an arrowhead like this, termination. Again I give something like this here. So look at, there is a minimum gap should be maintained. There is a minimum gap should be maintained between the object line and the dimension line. Say to be 12 mm. In the same case, here also that should be 12 mm. So if I give a value here, how should I write? I have to write this way, 50 mm. I have to write it this way, 50 mm. Here, this is one method of doing dimensioning. I have given a length and breadth for the rectangle. Consider these two. Let us consider these two are same. There are different methods for giving dimensioning. Let us go by method 1. In the method 1, I give dimension this way as we discussed. I give this way. I give this one. So let it be 40. Let this be another one. As I told you, this should be perpendicular to this one. I made this perpendicular to this object line. Now I make a dimension line which is perpendicular to this one, which is perpendicular to this one. So what happened? That will become parallel to the object line. The same procedure has to be followed. Here the value should be written in this way. I have to give this way. Look at, here I made it above. Here also I am making it above. Whenever we do it, we have to write it above. But at one condition, we need to write it on the left side. Look at that one. That is vertical. In that case, we cannot write it above. We have made it on the left side. We have to make it above the dimension line, or else we have to make it on the left side of the dimension line. You have to be clear. Then, as we did there, we can do it for here as well. For example, let it be F15. Just for a say, I give a value. Let it be 1515. It should be done parallel to the dimension line. Look at the values. 40 is done parallel to the dimension line. 20 is done parallel to this dimension line. 15 is also made parallel to this dimension line. This type of dimensioning is called aligned. Whereas another way of dimensioning is there. We can also look at those things. Here again, for this one maybe it's a horizontal thing. We can do the same thing like that. As we did, we can do it. Let it be 40. Whereas in this case, I do the same method, but there is a small interruption in the middle of the dimension line. There is a small interruption in the middle of the dimension line. Say to insert the value. Here the value should be written this way. The value should be written this way. Again, I do it for this one. Again, here also it has to get interrupted at the middle, and I have to give the value in the middle, say to be 15. The same thing. Look at these two. Here it is made parallel to the dimension lines. Here it is made horizontal to the diagram or to the reader. This is unidirectional. So this is aligned and this is unidirectional. In this case, it is not necessary to interrupt the horizontal dimensioning. Non-horizontal dimension lines should get interrupted at the middle to give the value inserted. That's fine. So this is aligned and this is unidirectional. You can stick on to any one of that. If you wish, you can follow this aligned, or else even you can go by unidirectional method. So here we have something more. In this case, we need to give dimension for all these things. For a particular diagram, we need to give all the necessary dimensions. Unless we give necessary dimensions, we will not be able to make the component correctly. So we need to give all the necessary dimensions. Meanwhile, don't duplicate. For example, if this is a rectangle, it is not necessary to give this 100 again here. It is known. The opposite sides are equal in length, as it is said that it is a rectangle. Meanwhile, we are going back to this one. Here again, we need to give dimension for all these things. Here again, we can give it like this. And I am adopting by aligned dimensioning. I do by aligned dimensioning. I can do this way. I can do this way. I can extend this way. Again, for example, if I want to give an angle here, I want to give angle. And again, here it's a center mark. I need to give this one. So I can use a diameter, say to be 30. This indicates diameter 30. For a circle, we need to give either diameter or radius. If I want to give radius, I should give it in another way. For example, I can give it this way. R 20. That means that radius 20 for this circle. Meanwhile, here there is another small circle. For this circle, it is difficult to make the thing here. So what I do, I can do it like this. The arrows are pointing inwards. And now we can say, let it be a diameter 20. So, diameter 20, but I have made it outside. Radius, I have made it inside. Remaining cases, the dimension values should be written outside. As far as possible, the values of the dimension or the dimensioning should be done on the outside of the diagram. In rare cases, when it is not possible, we can do it inside. Okay. So here again, I can give dimensioning here for all. As much as possible. Here in this case, I told you there should be a minimum of 12 mm gap should be maintained. We don't make it here. Instead, we make it here to get it uniform, to better looking. So we can do it like this. Again, we can do like this. We can give the values here. Then again, for angle, indication of angle, let it be. So here we can give it like this. And it can be marked like this. So let it be 45 degree. So the angle should be marked. The remaining values should be given here. Did you note that in the first diagram I made the unit next to the value, but I didn't mark these things? Yes, we have to mark. If not, we need to mention. In a particular drawing, mostly we will be following one particular unit. So rather than giving unit everywhere, instead we can give it at one place. I can give it like this. All dimensions or in mm. That will do. All dimensions. All dimensions or in millimeter. That will do. If I just mention this one, unless otherwise specified, I follow millimeter. Here in this case, I have given 45 degree because it's another unit. So if I mention this sentence, there is no need for making millimeter everywhere. So that looks better. Meanwhile, we are having some other types of things as well. So here we have plenty of dimensions to be given. For example, I give this way. I give this way. let the arrowheads be of uniform size appropriate to the diagram. For example, if the diagram is too small, don't make the arrowheads too big. Okay, choose the appropriate size for the diagram. For example, what I follow is for this arrowhead I choose 3:1. This head length to be 3 unit and this to be 1 unit. Then I just connect it like this. Then I fill it. The shape of the arrowhead will be in this fashion. But the size varies according to the size of the diagram. Okay. So here we continue with this one. So here I can give a value. Say let it be 20. Let it be 30 again. Here let it be 30 again. Let it be 20 again. So this is a way. Consider a similar component. Let it be of same size. I give dimensioning for this one. Let us see how I give. Look at this. The first one it is 20. The next one it is 20 plus 30 it is 50. The next one 50 plus 30 it is 80. I have to write it here. Then again it's 100. Look at this. Here I made dimension for each and everything in the same line. It is called chain dimensioning. Chain. And here I made dimensioning with parallel lines, parallel dimension lines. And here the gap should be maintained. I told you initially the gap should be around 12 mm. For the further cases, let it be 10 mm between the dimension lines. So here this is called parallel dimensioning. This is chain dimensioning and this is parallel dimensioning. In certain cases, we will be using parallel dimensioning in industry because the error possibility is less here. There it could get accumulated. Once when there is an error, it could get accumulated for all further dimensionings. So this is how we need to choose which one to be chosen. I forgot to say one thing. Here, look at this. The projection line has got extended beyond the dimension line. And that must not be too far away. Let it be say to be 3 mm, say to be 3 mm. For a smaller diagram, let it be 1 mm, the gap should be 1 mm and the extension to be 3 mm beyond the dimension line. Okay, let us continue. Here we have another component with some similar thing happening continuously one after other. Instead of giving dimensioning for all, I can give something like this. I can give a leader and I can give 4 holes. 4 holes, diameter 3. That will do. There are 4 holes. I just mark it at 1. It is understood. Meanwhile, we have other things as well. In this case, I want to give dimension for this. Look at this. Here there are some wavy lines, zigzag lines, continuous zigzag lines. Look back to the types of lines. If there is a continuous object, if there is a partial view, we just do it this way. The object is not over, it is still continuing. But I have looked at a particular thing. I just want to focus on this one. So I have made a partial look. So instead of making it straight line, we have to do it this way. Now I want to give dimension for this one. For this one, I just do this way. It is difficult to give dimension within that one because it is very less. So I give it this way. Let it be 2. That means that the internal dimension is 2 mm in our case as we follow the unit millimeter. In this case, here we have a thing. So radius or 5. Radius 5. In this case, if I want to give something like this, if in a case, if it is mentioned, this symbol is shown, it is a square. It is a square. It is just to say something like it is shown like that. It is a square of size 10 mm. Square with side 10 mm. We saw that earlier, radius r or else pi to diameter, or even if there is a sphere diameter, then s pi it is given, or else s r it could be given in that way. So look at the dimensioning. We need to give all necessary details. Don't repeat the dimensions. Try to make the dimensions legibly, make it outside. Whenever we give value, if it is 20 and 50, the smallest dimension should be given closer to the object. Once when we do like this, we will not have intersection of dimension lines. If you do the other way, if I give 50 initially, then I give 20, there will be intersection of dimension lines. So still you need to practice more on dimensions, as it is done on all necessary drawings. All necessary drawings should have all necessary details. Unless a drawing is given with all necessary details, we will not be able to make it. It is meaningless. So remember, drawing without dimension is meaningless. Do with good proper dimensioning, do's and don'ts. Just look at. Have a good time.